Now what we're doing is we're adding in binomial denominators. Now, we need to remember that for binomial denominators, we have to look at them when they're factored down as their own factors. And this is a key point here. So even though I have an x here and an x here, this one is actually the combined idea of x minus 4. Now, I can't factor that down any further, but that is an entire factor that can't be changed. On this side, I have 2x, which means that these denominators don't have anything in common currently. So I'm going to need to multiply the entirety of this side by x minus 4, and the entirety of this side by 2x. So really, once I factor down the denominator, I'm looking for all of the different factors that exist and multiplying out those factors in the denominator. This is going to give me x minus 4 times x minus 9 plus 3x times 2x, all over the 2x and the x minus 4, both my factors that exist in the denominator. I'm going to expand it out, and I'm going to wind up getting x squared minus 13x plus 36 plus 6x squareds in the numerator. And I'm still going to leave the denominator factored down, because I might need to simplify once it's all done. When I combine my like terms, I have 7x squared minus 13x plus 36 all over 2x and x minus 4. And the last step I would do is I would see if I can factor this down, and that numerator is not factorable. So I'm going to take a look from my lowest common denominator and state that based on that, x cannot equal either 0 for the x that's outside the brackets or 4 from the binomial that's inside the brackets. For example, b, can't factor this down, can't factor this down, so once again, I'm going to multiply it into the two parts. I'm going to need to multiply all of the 4 by y minus 3, and I'm going to need to multiply that -1, watching for that subtraction there, by 2y plus 5, all over my 2 factors on the bottom, 2y plus 5, and y minus 3. I'm going to expand it out, and I'm going to get 4y minus 12 minus 2y minus 5 over 2y plus 5 and y minus 3. And when I combine my like terms, I have 2y minus 17 over 2y plus 5, y minus 3. And looking at my lowest common denominator, this is true so long as y cannot equal either -5 over 2 or 3. Last one, I got a binomial on the top, binomial on the bottom, binomial on the top, binomial on the bottom. I'm going to watch for that negative. The factors are not the same in the bottom. I can't simplify them at all. So very similar process. I have 2x plus 1 multiplied by the factor that was missing on the bottom of the first expression, x plus 1. Don't forget that minus here. And I'm going to get x minus 4 multiplied by the missing x minus 5. And it's all over x minus 5 times x plus 1. I'm going to expand both these out, and I'm going to get 2x squared plus 3x plus 1 minus, and because it's minus, I got to keep this in brackets after I expand it out, x squared plus 9x, sorry, minus 9x plus 20. You got to be really careful here because once again, that negative is going to apply to all three terms inside of here, which is why anytime you have a subtraction, you need to leave the product in brackets. All over x minus 5, x plus 1, 2x squared plus 3x plus 1, and when I flip the signs, minus x squared plus 9x minus 20, all over x minus 5, x plus 1. And this is going to leave me with x squared plus 12x minus 19 over x minus 5, x plus 1. I can't factor down the numerator at all, so I just need to state that this is true so long as x cannot equal either 5 or negative 1. Just like we did at the beginning, it doesn't matter how many different rational expressions you are adding or subtracting together, you're still doing the exact same process. So, when I take a look at these, I can't factor down any of the denominators. They are all their own factors, which means that in order to put them all over everything that I have here, x, x plus 2, and x plus 1, I need to expand it out and add the missing denominators to each of these numerator terms. So the first one already has the x plus 2, but it's missing the x and the x plus 1. So I'm going to take 3, and I got to multiply it by x and the x plus 1 to make that numerator match. I have a subtraction next. The second one has the x plus 1, but it's missing the x and the x plus 2. And the last one has the x, so it's missing the x plus 2 and the x plus 1. I need to expand all these out properly. So if I have 3x times x plus 1, then I have 3x squareds plus 3x's. Negative 2x times x plus 2 is going to be negative 2x squareds minus 4x's. And finally, this multiplied by 1 isn't going to change what the result of this one is. And it's positive, so I don't need to worry about that. So now I can just expand out x plus 2 times x plus 1, and I'm going to get x squared plus 3x plus 2 all over x plus 2, and x plus 1. I'm going to look for all my x squareds and combine them. I'm going to look for all my x's and combine them. And I only have the one constant, which means that if I did this properly, I'm going to be left with 2x squareds plus 2x's plus 2 all over x plus 2, and x plus 1. And I still need to check to see if I can factor down my numerator. So I'm going to start by saying, well, there's a common factor of 2, x squared plus x plus 1. But this is not factorable any further, which means that there isn't a common factor in the numerator and denominator, and then I just need to take my lowest common denominator and find all my non-permissibles. So this is true so long as x does not equal either 0, -2, or -1. And there's my final answer. All right, go ahead, try some practice.